Eric Burgess here, and we've been given a sequence and they want us to rewrite a formula that can reproduce this sequence. And as a reminder, we're going to use the variable n. N starts at 1 and just continues on and on and on in integers forever. So this should be old news by this time. This is our third video on it. So let's go ahead and look at this. Now this one is just numbers, which can sometimes be significantly harder. In this case, what I like to do first when it comes to just numbers is if I don't notice any clear pattern right off the bat. So here, there's not any sort of multiplicative thing going on. Let's just see what the difference is between the numbers. That can often be a great place to start. So 5 to 8, that's a difference of 3. 8 to 11 is also 3. 11 to 14 is 3. And 14 to 17 is 3. So we have discovered the pattern here. It's increasing by 3 each time. And so we say, well, okay, this first one increases by 3, but to go from like 5 to 11, that's 2 3s, right? That's 6. To go from 5 to 14, that's 3 3s. And so there's actually, it is kind of a multiplicative thing that's going on here, right? It's 3 times 1, 3 times 2, 3 times 3. And so what we're going to do is we're going to say, okay, well, 5, what do we need to do? Because we want n to start off at 1. And so let's just look at it like this. We could say, well, okay, 5 minus 3, that's 2. So there's this leftover part 2, and then we'll add to it 3, just 3. Let's just stay at 3 for now. So this is going to give us 5. If we want to get to 8, we need to add another 3, right? That's what it says right here. And so we would go another 3. So we need 2 3s. And if we want to go to 11, we would add another 3. And so on and so forth. So however many 3s we need, we'll call n. So the first to get to 5, we need 1 3. So that's 2 plus 3 times n. And now to get to 8, we need 2 3s. We need the 3 to get to 5 and the 3 to get to 8. And so we put n is 2 and we'll get 6. 6 plus 2 is 8. To get to 11, you need 3 3s, and hopefully you can see the pattern. It just continues on and on. This one, I think some students get it right away, and sometimes it can be really confusing because you see this 5 and you feel like you kind of have to use it, but you actually want to break it down. There's an extra chunk here. This is like our extra little offset at the start, and this is where the pattern really is. And so this is how you would reproduce this sequence. And if you see one like this, try out this sort of a method. If you see a constant difference, take the first term and split it apart, so that you can put in your n equals 1, 2, 3, and it should come out actually pretty simple most of the time. So this is our solution. If you have any questions about this, feel free to let me know. Subscribe and hit that bell icon for future videos, and we'll catch you in the next problem.